First, let's find the value of each perpetuity. Recall the equation the value in time period 0 equals the payment in time period 1 divided by the interest rate. So the value is calculated at the time period before the first payment is made, and this is when we're finding the value of a perpetuity. Before we find the value of each perpetuity, we need to find the effective annual rate of interest. The nominal rate is 12%, and it's compounded 2 times a year, so we can put the following into our calculator. Nominal percent of 12, periods per year of 2, and now the calculator will find the effective rate for us. We just press effective percent and we see that the effective annual rate of interest is 12.36%. Now we can find the values of each perpetuity. The first one makes payments of $500 starting in year 12. So the value in year 11, the period before the first payment is made, is just 500 divided by the interest rate, 0.1236. Now when we're using this formula, we have to input the interest rate as a decimal, which is just 0.1236. Whereas when we enter interest into our time value of money functions of our financial calculator, we put it as a percentage, so we would put 12.36. So make sure you understand that distinction. We solve for the value in period 11 of this first perpetuity to be $4,045.31. Now, since we ultimately have to find the value of all 3 perpetuities at year 27, let's go ahead and compound this value forward. There are 27 minus 11 equals 16 periods we must compound this sum forward at an annual rate of 12.36%. So basically we found the value of this first perpetuity in period 11 to be $4,000 some odd, and we need to compound it forward into period 27, since eventually what we're going to do to find the value of all 3 perpetuities in period 27 is find the value of each one and then just add them up. So first, make sure to set your calculator to 1 period per year, because we're going to use our financial calculator to compound this value forward. Then we can input 16 in for n, since there are 16 years from period 11 to period 27, 12.36% for the interest rate, and the present value we just found to be in period 11 is $4,045.31. Now we can solve for the future value, which is going to be in period 27, and it's going to be $26,105.93. Let's repeat this process for the second and third perpetuities. The second perpetuity begins in year 27 with payments of $750. So the value in period 26, the year before the first payment, is 750 divided by 0.1236, which is $6,067.96. So there's 27 minus 26 equals 1 period that we need to compound the value forward at the same interest rate, since the value is in 26 and we want to again get all 3 values in a period 27. So we can find the future value in period 27 of this perpetuity by adding the following into our calculator. 1 period, 12.36% for our interest, and a present value of $6,067.96. We just solve for the future value and we get $6,817.96 is what the second perpetuity is worth in period 27. The third perpetuity starts in year 33, so the value is in period 32, $900, which is the payments of the perpetuity every year, divided by 0.1236. And we see that the value of the third perpetuity in period 32 is $7,281.55. We need to discount this value back because it's in 32, which is past period 27, and we need to discount it back what the difference is, which is 5 years. So let's put this value into our calculator as the future value, and then we can solve for the present value. So again, we're going to put in 5 for n because there are 5 periods between period 32 and period 27. We're going to put 12.36 for our interest rate, and we're going to put a future value of $7,281.55. Now when we solve for the present value, we'll get $4,065.98, and that's the value of the third perpetuity in period 27. So the value of all 3 perpetuities in year 27 is the sum of the value of each perpetuity in year 27. So we just add up our 3 answers, and we get that the value of all 3 perpetuities in year 27 is $36,989.87.